Um,
Oh,
Good afternoon, everybody. I want to thank you for joining us. Today we welcome guest speaker Hans Muhlert. Hans holds a Bachelor of Science degree in Naval Architecture and Marine Engineering from the University of Michigan. He is the Senior Project Director at Robert Allen in Vancouver. He's a traditionalist in design styling and progressive in the use of the latest design tools and methods. Hans has 50 years of professional naval architecture experience. He's a registered professional engineer in British Columbia and a member of the Society of Naval Architects and Marine Engineers, SNAME. In fact, in March 2020, Hans was awarded the status of fellow by SNAME. And this significant distinction is, and I quote, accorded exclusively to individuals who have made outstanding personal contributions to naval architecture, marine or ocean engineering, or allied disciplines through significant achievements in design, research, production, operation, education, or associated management. Hans enjoys mentoring the student naval architectural design teams at the University of British Columbia. He is an avid competitive and leisure sailor and enjoys boat building and house renovation. So it is my pleasure to introduce to you today, Hans Muhlert.
thanks very much. You can all hear me, I hope. Thanks for the glowing introduction. I'd like to thank Leslie for inviting me. And I would like to just go over what I learned in the last 50 years since graduating from Michigan. I don't want to give advice to anybody, but I can tell you what I learned. Might be useful. I was in Michigan at 1965 to 68. And that's me there at that time. Let's go through the credentials. I earned a bachelor's degree in 68, and I started working at Robert Allen Limited in 1970. I became the office manager there. In 1979, there was a sort of a life-changing opportunity. I was seconded to a shipbuilder in Singapore for 3 years. For a completely different lifestyle and responsibilities. And returned in 82 to quite a downturn in the economy at that time. With the skeleton crew, but we persevered. I'm a registered professional engineer in BC and a SNAME member. And now I'm semi-retired, but I'm still doing naval architecture. The type of work I do is basically design of workboats. I have to give the university credit for getting me off on the right foot. I really couldn't have done anything without the experience and the education I got at the university. When I got there, I was basically an artist, but I had to sort of become an engineer. I'm still basically an artist, but I do the engineering to make the artwork work. At Michigan, I was introduced to SNAME, and I was fortunate enough to go on a couple of field trips to New York to the annual meeting. And as part of the student delegations, at that time, we just all piled into a car and we drove all the way to New York from Michigan. And that gave me the opportunity to meet some key industry people. One thing I wanted to say was that, although at the time I didn't think so, I can see now that there was no useless courses Um, when I was there, I would grumble about I have to take this course and I have to take that course. But turns out I needed everything, even the ones I didn't really get very good at. And there was a great relationship with professors at that time. I'm not sure how the department is arranged now, but at that time we had a big study hall at the far end of the engineering building, the fourth floor. And there was a whole bunch of drafting tables there, and we were each assigned a drafting table. And around the perimeter in that space was a lot of the professors' offices. So we could wander in and talk to a professor, after checking that they weren't too busy. That was really nice to be able to do that. And I also took a job down at the model basin, which at that time was very active, and helped on the carriage and then processing the numbers. That was a lot of extra education that's even useful now. There was a quarterdeck club. I don't know if that still exists. And of course there was a sailing club. So in the time since, the 50 years of naval architecture work, there's some lessons learned. One of the big ones is Shipyard Experience. Whenever I get into a shipyard, there's a lot of things to learn immediately. And at the short times when I've actually worked in a shipyard, you get to see the product of your work immediately. And if it doesn't work, people will come upstairs and tell you in plain language that what you did doesn't work. Sea experience I also found very useful. Haven't had too much of that, but I was able to go on some trial trips and a guest on some vessels. And of course, sailing time for me, it's really not directly naval architecture, but you still get a lot of useful experience. And then amateur boat building and maintenance. So it's I kind of like building boats or maintaining boats, and that sort of taught me to relate to the hardware. So hands-on experience, some examples. Some are good memories and some are not so good memories. The sea trials on the 84-foot crew boat, that's the one on the right there. We did that in 1980 in Singapore. And my boss was enamored by some water jets that produced in Italy, which we purchased and installed in the boat. And on sea trials, they didn't work at all. In fact, they start falling apart after a few hours running. So that was a disaster. And they put the boat up on stocks. But fortunately, the owner came back and in about 6 months or so said, well, get this thing going. And I actually personally went to New Zealand to Hamilton Jet and negotiated some new jets, which they were thinking of building, but they hadn't built yet. And we purchased those and eventually put them in the boat. And lo and behold, it worked as it's supposed to. So that was, it ended up pretty good. A bit of a painful experience. Other hands-on experience, like I was able to go out in a fish boat out of Boston. And that's a whole different world. And you learn a lot there. Another thing was a stay on the Queen Mary. The Queen Mary in Long Beach is actually available now as a hotel. You can stay there as a hotel. So that I was able to do that. And of course, that boat is full of history. It was a very successful vessel. And I wandered all over the boat and took pictures of everything. And on the right there, you can see an expansion joint. That expansion joint goes right across the ship. There's a couple of them, which is really interesting. So everything above that level was not contributing to longitudinal strength. And I was able to get on some tugs for sea trials. You get to learn things like what cavitation sounds like. Sounds like gravel going through the propeller. And the yard visits, there's a picture on the right of a tug being prepared for launching. So another thing that I found was you can't really rely on so-called proven designs or things that worked before. And you think, well, they're going to work this time because they worked before, but sometimes they don't. The most painful one was this police boat on the left. This one that I did in Singapore. It was very successful. They built 19 of them. They all worked very well, 32 knots. And about 20 years later, I got a chance to do another one for New York. And I figured I knew how. But it wasn't exactly the same. It was ice strengthened, and there was various other things that were different. And it didn't work very well at all. It took us months to get that boat going properly. So I should have recognized that it wasn't the same as the other one, even though the dimensions were the same and the propulsion system and everything. But it's a lesson learned there. And that launches me into another negative subject, which is failure, which is something I've learned that happens sometimes. If you do a lot, I did a lot of things, and some of them, most of them worked, but some not. So there's quite a lot of risk there. And I think if you work in the US, you have the additional liability risk there. And the professional liability is quite expensive. And if you make a claim, the insurance is okay as long as you don't make a claim. If you make a claim, then they don't want to insure you anymore. And I always remember Mr. John Hamilton in New Zealand telling me, it's not so much the mistake you make, but what you do after you've made the mistake. And I try to remember that. If you deal with it properly and learn a lesson and find a way out professionally, then usually it's kind of redeeming. And then occasionally I run into problems when team members in my design team make mistakes. What should happen is if they should own up and say we made a mistake, and then the whole team figures out, okay, how do we fix this? But it's really deadly if they make a mistake and don't tell anybody. I've got to really watch that when you're working with a team. But most of the time there's successes, and there's nothing more gratifying than when things actually work properly. And the boat makes the speed, or it looks good and floats on our lines, and the customer is happy, and the boat makes money for them. That's makes you think it's worthwhile being a naval architect. It's also gratifying if you can do all of that on budget as far as your design job goes. But I've learned that the main thing is to get the boat working properly, whether you make money or not. Just get it to work properly, because your reputation rests on that. And like I mentioned before, most projects are not individual efforts, they're team efforts. So if the team members come up with a good idea, then I think I like to give them credit for it. It makes everybody work hard and pull in the same direction. One thing we've done actually relatively recently in our office, last sort of 15 years or so, we've instituted a formal checking regime where everything that is of any consequences has to go through a formal checking where somebody else in the office checks the work. And you'd be surprised how much they find sometimes. It seems to be a nuisance and it's time consuming and it costs money, but it sure saved our bacon a few times. And then there's still a few things that get through. There's still a few things that get through all the checking and everything. And you have another little fire to put out in the shipyard. And like I've said, most projects are done by teams of people. And as a team leader, I've had some challenges with what I call watertight subdivision between the team members. We like to get all the team members to talk to each other, and when they change a design, if they move a hatch or do something, to tell everybody. But you'll get a few individuals that don't do that, and they'll make a change and don't tell anybody, and then like weeks later, when you see, oh, my propeller shaft has moved, and there's 5 other drawings that have that on it, nobody knew. So it's a challenge to as a supervisor to get everybody to work together and to talk to each other. And it helps. Again, if you give them credit when they do a good job, it helps the team pull together. And the other thing I've found is that you have to, and I guess this is for any sort of professional, you have to continually educate yourself. We get a good start at Michigan, but we have to keep up to date. There's always new developments and other people coming up with good designs and stuff. So you got to spend some time looking at the news, and the journals, technical papers. I do get SNAME technical papers and from RENA, the British organization, but and I try to read them all, but it's kind of overwhelming. So you have to be kind of selective what you read. And half of it is beyond me technically anyways. But there's a lot of things that even like everyday job, like designing a propeller, I've actually learned from others. And of course, SNAME meetings are very educational. So I've tried to go to the SNAME meetings, and that's become a different format now. I've just attended a marine engineers meeting where the whole thing was a video conference with 20 people on the screen. And then at Robert Allen, we usually hire a couple of students every term, every semester. And I've actually learned a few things from the students too. They bring in what they know and we learn from them. So they learn from us and we learn from them. The interesting thing is how we do things differently now. At university, we used the planimeter, and there was a great big integrator, which they sort of were very protective about. But if you asked them nicely, they would let you use the integrator. And of course, we had courses on how to do lines plans by pencil and paper, and splines and ducts and ship's curves. And as I mentioned at the top, we were all assigned a drafting table in the big drawing room upstairs, and pretty well had that table for the duration of our stay there. and did our lines plan training and midship section drawing training up there. And that was the time when the calculators were still manual, and they were like a typewriter. They're a big machine with buttons and cranks and stuff. Shortly after that, electronic calculators came on the market. But when I was there, we used slide rules for most calculations. And there were computers, of course, but they were giant and they were taking up whole rooms. And any time on the computer was extremely expensive. We were given a budget of so many dollars, and you tried really hard not to get into an infinite loop in your software and use up all your money just like that. And now things are different. Everybody in our office has a desktop computer, and the computer drafting, it's always been around, but it became affordable sort of early 80s. And people like myself that got quite good at manual drafting had to retrain computer drafting. And I didn't actually mind that. And I got, I'm much better now at computer drafting than I was at pencil paper drafting. And so all drafting is now on the computer. At the University of Michigan, we did learn about finite element analyses and basically what that is. And we actually wrote our own software to try to run it on some simple projects. Now we use proprietary software, and it's just quantum jump faster and better. Do it on a desktop computer. And projects where we need to get classification society approval, we can actually share the FEA report with the classification society, and then they'll review it and approve the design based on that calculation. Because sometimes you do step outside the rules that as published. You have to do something a little different, but then you have to substantiate that it's that it meets their requirements. Of course, now we do a lot of 3D modeling. That existed back in my time, but was only done by big computers, and I think they were using it in Detroit for designing automobiles, but we couldn't get our hands on that. And now it's everybody. All the students that we bring in as work term students are highly trained on 3D modeling. It's really quite amazing. Some of them are just extremely good. And this is a model of a 35-meter high-speed self-righting fireboat. And I think this helped get that contract job, because it was very competitive to get that job. But I do notice that, like my title here is, it's a modeling tool. It's not a toy. I do notice that a lot of the students come in and they want to model everything. And I try to slow them down and say, well, you got to do the basic naval architecture. You can't just make a model and see if it floats. You should go the other way around and figure out what that model should look like. But continuing on that 3D capability, I was going to run this picture here. That's the same fireboat, but the young people in the office made a video for promotional purposes. So I'll just run this, and hopefully you can see that. This is all just computer modeling. That's an aluminum boat, a triple screw fireboat, but the customer in their wisdom wanted it self-righting. So we had to calculate it, stability to 180-degree range and make sure it was positive the whole way. So basically utilized the buoyancy of the deck house and the deck structures at the back to bring you back upright. And it has to be right. They're going to actually pull it over with a crane and roll it over. But here's the modeling that was done. They actually took it a step further, and they gave me a headset with goggles and a hand control, and you can actually move around the boat, literally. So visually move around the boat and look at everything. We did get this job, and it's now we're designing it for construction. And the other nice thing we can do now that we couldn't do, in fact, I don't even think it was on the horizon when I was at the university, was this CFD, Computational Fluid Dynamics. And this is the most amazing tool. We can see everything. We can see what's going on. We can see the flow around anything. We can see the propeller, the flow around the blades, where it's cavitating, and flow over things that you would think would go this way, it goes that way. So this has really opened our opportunities. There's go to the next slide here. There's things we can do now that we wouldn't dare to do in the past. For example, there's a form of semi-displacement high-speed hull that I've been using for the last, I don't know, 30, 40 years. And I really didn't deviate much from that form because I didn't know, would it be better? Would it be worse? If I stuck with the form, I got data to show that it'll work. And that's in practice happened that it worked. But now we can, with CFD, we can change things. So we can move the LCB or change the hull shape or something and know what happens and have confidence in that. But I think in over 50 years, what happened between when I was there in late 60s and now, and if you look from your perspective, okay, you're starting out now, look forward 50 years, I'm kind of curious as to what you will think of what we got now. You probably think of what we're doing now as archaic and how you do it in the future, I don't know. The other thing that people never talk about is money. At the time that I graduated, the economy was quite good, and the employers were lining up literally at the university for interviewing students for employment, and I was able to get a job right away on graduation. And I insisted on being a design-oriented naval architect, where I would design boats. I didn't want to be a cog in a big machine. So the job I got was, it pays well, but it wasn't as high paying as some of the other ones that were available at the time. But still, I have to say that over the years, I've done fairly well. I'm 76 now. I can retire if I want to, but I keep going because I like to work. And it's still fun. So, but financially, I don't have to. I can stop now. So to summarize, I mentioned the University of Michigan, really what made everything possible for me. And I mentioned lessons that I've learned for hands-on experience, risks of relying on things that worked before without properly checking that it will work this time. Having to deal with failure and enjoying successes. And importance of checking the work, independent checking of the work. And the importance of teamwork, I mentioned that. And I had to keep on, and I still have to keep up with new developments, new techniques, new hardware that's available, and which enable me to prepare more competitive designs. And we do have to keep up with the tools. I have to keep up with the tools of the trade. I don't do the CFD, but I have a really smart group downstairs in our office that runs the CFD system, and I avail myself of their services. And actually, they've bailed me out on a few problems where I've come up with something that didn't work, and they were able to analyze it and find what's wrong and how to fix it. I could go on for a few of those. And then I mentioned the financial picture of being a naval architect. So hopefully there's something there that that you could find useful and enable you to do lots of interesting boats. And I thought we could close by looking at some boats, some boat pictures. This is stuff that I've done. This is an 18-meter Z-drive tug. This is quite successful. They're up to about number 15 or so on the construction of these. And I always like doing high-speed performance vessels, and this is a high-speed fireboat for the city of Philadelphia. Has 4 engines and 4 water jets, and when it's fighting the fire, the 2 middle engines drive the fire pumps off the front. So, and that was still very much in service. And one of my earlier tasks was a ice-breaking supply boat for when there was lots of exploration going on in the Canadian Arctic. And they all went up there and did a lot of good work. I think most of them are still around. Another fireboat. This one is not as fast as a Philly boat. Philly boat was about 30 knots. This thing is about 16 knots. Aluminum, conventional drive. And a police boat, catamaran with surface propellers. I'm not sure if you're familiar with surface propellers, but just the bottom half of the propeller is in the water, and they're extremely efficient at the high speed. And a more conventional crew boat built in Sri Lanka. They built 4 of these in Sri Lanka. This one is shallow draft, which meant it had to be more beamy with tunnel sterns. And there's another high-speed boat. This is a 45 knot boat with twin water jets. And it's really something going 45 knots over the water. You have to plan ahead. Things that look far ahead of you in a moment are not that far ahead of you anymore. So you got to plan ahead to going that fast. And there's another early job we did in 1972, truck trailer and rail car ferry for Eastern Canada. And they're taking good care of this one. It's still in operation. It's about 420 feet, I think. So ice breaking. And I couldn't resist putting this one in. This is a picture I got just last Monday of one we did. 2 boats like this, 39 feet, line boats. And this is another one where you sort of gyrate between success and failure. The boat, we did a weight estimate for this boat, and we did an internal check on that weight estimate, which was good. And then the builder did a weight estimate, did his own independent weight estimate, and it agreed with ours. And yet when this thing was launched, it was trimming by the bow and a ton overweight. And I started to worry, well, how am I going to make the speed like that? Because there was a contract speed. And trimming by the bow meant that we had to add another ton in the back to level the boat out. And so now we're 2 tons overweight. But we did make the speed. So everything ended up happily. I don't know why that LCG moved forward so far. I think the customer is, or the builder is used to building nice, beautiful interiors with teak trim and stuff like that. They probably added too much weight in the outfit, because I was pretty sure that if you got 2 independent weight estimates that are agreeing that they're not wrong. So anyways, this boat turned out okay. And then I just got to repeat that none of these are designed by just me. It's always a team. And so everything is a bit of a team. Teamwork. So that's the presentation. Thanks for being here, and I was happy to put on this presentation, and again, thank Leslie for inviting me. So I'll just stop share the screen. Here we are.
My pleasure. I'm so glad that you were able to join us today.
So I haven't heard anything from anybody, so I think everybody's gone to sleep or what?
Hans, can I ask you what brought you to the University of Michigan, and did you know you wanted to be a naval architect when you came here?
No, I knew all about that. I was quite determined to be a naval architect, and at that time the opportunities were limited. There was nothing in Canada, and in the US there was Webb Institute, which at that time they're all on scholarship. That wasn't really available for a Canadian. And Michigan seemed to be very interested in having me give it a try. I also wrote to Newcastle in England, and they never replied. So, but it turned out very well. I was quite happy because as a young person being in a different country, the first few months are kind of daunting, but it worked out pretty well. And of course I had to get a job right away because my parents didn't have any money for the education. So I had to get a job right away. But the job down in the towing tank helped a lot.
Well, it's, I know a lot of the tools may have changed in 50 years, but I got to tell you, there's a lot that remains the same. You mentioned SNAME and going to the annual meeting, and we still try to send as many students as we can. We couldn't go to Houston last fall, but we're really hoping that we can go to Providence in October.
Yeah, that was very beneficial for me. I think it would be for anybody to be able to have that experience. In
Yep.
those days, it was always New York. Every year it was New York, and then at some point there, they changed the way they do it, and now it moves around.
Yep, and even though we're up here on North Campus, we still have the towing tank down in West Hall, and we still have students that are on the carriage and processing.
Oh yeah.
Yep, and quarter deck club is still going strong.
Good. That was another one that was good for the guys to get together and talk about stuff. Yeah.
The drafting tables are gone.
They are, right? Is the study hall gone?
No, well, in our building here on North Campus, there's still a big room at the end of the hall where the students have their space. Now they're computers instead of drafting tables, and the faculty offices are pretty close by. If it weren't COVID, we'd have a lot more interaction, but of course, this year looks pretty different.
Yeah. Well, that's one thing. This COVID thing has been really bad for a lot of companies, people, but I think our business, we haven't really missed a beat. We've continued to have contracts, and everybody in our offices is really busy. So I guess as naval architects, we're fortunate. But I did find that we are quite sensitive in our work with what's going on in the world economy, and we seem to have a lag. If there's a lull in the world economy, we see it a little bit later, but we definitely see it.
Yeah, and things in Canada are pretty locked down right now, right?
Yeah, trying to get organized for this pandemic, but we still haven't got good control of it. Seems to be things are starting to get better down in America. Huh?
We'll see. We're all waiting for our vaccines.
Yeah, I'm waiting for that too. So, anyways.
One thing, I want to make sure all the students here heard you say that there were no useless courses, even though you might not have thought so at the time.
Yeah, I wanted to mention that because you get to the situation well, at least I wanted to focus on naval architecture and engineering, and they would come, well, you got to take a statistics course or something, and but all that stuff's become useful later on. Even the ones I should have learned, it would have been better if I had. Differential equations, that was a tough one for me.
Yeah, I don't know anyone that enjoys that a whole lot. Do any of our students have any questions before we let Hans go?
Hans, I was going to ask what got you to Canada and to Vancouver area. I guess sounds like you're from Canada originally, but I was curious.
Yeah, I was from the Vancouver area. So and there was a well-known naval architect, Robert Allen, that I very much respected, and I didn't really think I could get the job, but they did accept me at Robert Allen. And at that time it was there was about 12 people there in the office, and Mr. Allen, as we called him, he ran everything. Now we're on the second generation of Robert Allens, and up to about 75 people, and managed to keep competitive. So I was quite fortunate to be part of that sort of growth expansion. And of course, the work's become international. At that time, it was mostly work in Canada, but now most of the work's actually international. Some of it's in the United States. I was worried about Biden's Buy America. That would rule us out, but not yet. And but we have projects in Hong Kong and in Taiwan and China and Singapore, Turkey. So it's sort of been all over, which is probably smooths things out when the economy takes a dip.
Mhm. I think the other question I had was, it sounds like you have a bit more of a sailing background. Was there any other industries you considered, or it seems like you've been at Robert Allen kind of in the workboat industry for a while. Is there anything else you would have liked to go into, or were you happy
Well,
with
I
that?
started out wanting to design sailboats, but quickly learned that you can't really make a living that way. I mean, there are a few people that do, but the average person like myself wasn't going to make a living that way. So you had to quickly figure out a plan B. And there was some large companies that were recruiting, and the Canadian Navy was offering a very attractive package where they would pay for the university if you agreed to work with them for 5 years afterwards. But I was sort of anti-military.
Well, thank you so much. Really appreciated the comments, and it was a great presentation. Thank you.
Thank you.
Hans, I have a question. How often do you get out on the water, whether it's through work or pleasure?
Well, it used to be pretty well every week, but not so much anymore. Really have to I can't think only of myself. I am married, and my wife has some mobility issues now, so she needs a lot of care and attention. So I kind of look at things going on, but I try to help here.
Yeah.
But for many years, I was out in the water just about every weekend.
Mhm.
And then I was actually able to go on the Hawaii Transpac race one year. So that was quite an experience. We have, there's the one that starts out in LA, I think, but there's another one that starts out in Victoria. It's a tiny bit longer. 1978. I went on that one. That was quite an experience. And for a naval architect, it's you do learn a few things about that too.
Nice.
But getting out on the workboat wasn't so easy. And every time I did, I was like a sponge. I tried to learn everything I could in the short time I'm on the vessel.
That's great advice as well.
Yeah, it's a little hard to get on sometimes, but it's worth the effort. And it's a little bit hard to become a sort of a credible naval architect if you've never been out on the stuff that you've designed.
Do we have any other questions out there? Well, Hans, I just again want to thank you so much for your time and for the lessons that you've taught us today, and sharing your experiences, and the pictures. Just you've had quite a career, and it sounds like you're continuing to go strong. So
Yep.
stay healthy and safe. And
The thing is, never make the same mistake twice. Always make new mistakes.
that's good advice for everybody.
Okay, well, it was my pleasure and honor to be here. And it's a little weird looking back 50 years and now look at a group of people that are where I was 50 years ago. And where will you be 50 years from now? I don't know.
Mhm. Something to ponder. For sure. All right. Well, with that, we will say goodbye and have a wonderful day. And
Okay.
hope to see you soon at some point in time.
Yeah, sometime I should get back to university.
Yep. Or maybe even at SNAME. Maybe some of the students will
Yeah,
see you
that's
there
true.
at some
Yeah.
point. Mhm.
Okay,
Okay.
well,
All right.
thank you for having me.
Thank
So,
you.
Goodbye, everybody.
Thank you,
Goodbye.
Hans.